All right, welcome back to the next video in the series, Griscom and land use land cover change using modis and dynamic world imagery. In the last video, we kind of calculated this weighted average biomass density estimate for Indonesia and also the total carbon market's potential. And I said that I would complete it for Mozambique and show it to you before we start on the land cover change analysis. And that is what I've done here. As you can see, it's the calculation is really very similar. You get the median tons per hectare at a per hectare level and not a per pixel level. And then we kind of weight that based on the number of pixels we have. And then we add that together to get a weighted average tons per hectare. As you can see, even though the free forestable area in Mozambique seems to be higher from the Griscom evaluation, the forest seems to be yielding a lower tons per hectare as compared to the Indonesian evergreen rainforest. Um, I think, but it still has a sizable amount in carbon market potential, which is about 2.2 million tons if the projects can be reforested to the extent for which there is potential. Um, I still think that you shouldn't be guided too much by the Indonesia reforestable area because we know that we have a challenge with the resolution of the Griscom dataset to handle the polygons, which are at best 100 to 200 meters wide from certain tributaries. So that's not the best data set to rely on for Indonesia. But here for Mozambique, I think it's pretty reliable because you can see how there are reasonably enough pixels here to make a good estimate. Okay, so with that done, I think we should be moving on to the land use land cover change using modest data. And I will start talking through the pieces once again, which we started off a while ago, but I had to stop and reorient a little bit. Um, so as you can see, these are all the pieces that need to come together on this slide. There's a map, there's total area, there's current land cover, there's average deforestation rates, which are derived from total forest cover derived. So these two parts of the puzzle are kind of linked. We have to build an estimate for tons per hectare, using which we then need to calculate net plus potential, AR potential, and net carbon market tonnage. So that is really the name of the game, and we need to start building the pieces. So for Mozambique, at least, we've been able to go ahead and build the entire image here, and we also put in the entire area for Reserva Recreativa that we know about 175,130. Great, so let's go and replicate this now for Indonesia. I'll be doing these pieces simultaneously for Mozambique and Indonesia, and I will keep talking through them as I do them. So uh, just be prepared to follow along with me as I keep making switching from Mozambique to Indonesia and to different parts of the analysis. So now I'm going to go build the map for Indonesia. So here we are in South Sumatra. This map needs political boundaries, which I don't seem to have. I don't really need the Griscom dataset at this point. So what I probably need to add at this point are the political boundaries here. And I need to kind of shade this a little bit differently to indicate that this is forest area that we're considering. So I will go ahead and do some of that. We typically shade that in a dark green and it's a fill. It's not a line, sorry. So I'll go pick out a dark green like that for this. Okay, that looks fine. But again, not nearly as well as we would like. I'm probably going to then go and add another piece. And really, instead of that, I'm going to do line outline. Outline, simple line. Yep, and I'm going to also make that some kind of dark green there so that we get a little bit of that as well to show the extent of the forest. I think this is much better and far more representative of the polygons we have. Now I need to add on an Indonesia political boundaries data set in the background. And if I remember right, we had downloaded that for the purpose of this analysis in our very first video, and I do have that right here, so I don't need to download that any further. I can just drag it in. Great, looks like we have the political boundaries. I'll move it behind there. Okay, great, we have a view for where we are, and it is pretty clear we are in Sumatra. So let's just go in there. We will reduce that so that we have a clear view that we are in South Sumatra. I think that is a much better indicator now. Yeah, that's fine. This is even better. We have the word South Sumatra there. Great. Alright, let's bring that in. We just need a little bit of zoom here, which we typically don't add to these slides because it's quite hard to orient or see the forest if you kind of make it at the scale of the entire country. So I'm just adding this additionally as a visual, but then we should be kind of adding something like this as well to the background, and we don't really need a base map. If you remember, this is purely Sumatra. Okay, great. So we have political boundaries map from where I can show that this is where our forests are. Right. All right, now drawn that association here. That is excellent. And here I need to be adding some indications of where we are. Some Indonesia is all I really need to say. I don't need to get into where within Sumatra we are. And we know that this is the reforestable area. We don't need to say anything about that. I just need to then next add this box, which is about the total area across all the three forests. Interesting. Should we be breaking this down by forest? I really think that could be a good idea. So I'm gonna actually break this down by forest, what we're looking at, so people get a much better idea. Okay, let's build a slightly better visual here. So we know there are three forests: Benakat, Subanjariji, and Martapura. We have all of that going on here, which is excellent. And we can have a total. And I have included this kind of breakdown in other similar analysis I've done in the past as well. So let's go in here, Indonesia. We know that the total area we're trying to break down and really look closely at is a 16,000 hectare area, which is identified as shrubland or semi-shrubland for reforestation, specifically in the context of this client and piece of work. Order, bring to front. Great, this looks much better. Saves a lot of space. Okay, let's move all of that somewhere there. Okay, we're in good shape. So we just need to then break down, and we know this isn't, we don't need kilo hectares. We'll just operate in hectares. Now let's go break down that area quickly. Okay, here we are. We have this in three buckets, like you see here. And I want to make three different polygons, one for Benakat, one for Subanjariji, and one for Martapura. It's going to come useful in our analysis in the future. I'm going to select the select features tool, draw a box around all of these features here in Benakat, and then I'm going to export save selected features as. I'm going to create a new shapefile layer in the Indonesia MHP data shapefiles path, and I am just going to call this Lanaka underscore. Let's not put the area, let's just call it Lanaka. And we just check the coordinate systems, WGS84, everything seems fine. Okay, great, that's right. Great, so as you can see, a new area got created here that's only Bonacat, and we're just going to replicate the same for here for Subanjariji. Export save selected features as. I'm gonna go and ideally be located in the same folder. Yes, I am. We need to call it Subanjariji. Save. It's 84, looking good. Done. And finally, the last of the three regions. Export save selected features as Martapura. Excellent. So we've generated these polygons, and now I will quickly try to get the area of these polygons so we can quickly add it in. So I will just quickly do that. So the way to do this is using something called a field calculator, and we want to calculate. We've chosen Martapura here, and I think we want to calculate an area, area in hectares as well, and there's dollar area as well. So I'm just gonna put that. So it just shows that I have all of these things I can calculate. And once I do, okay. Yeah. Okay. So it seems to have added this in for Martapura. Look at that. All the four polygons now seem to have an area, and I think this is in meter square and not in hectares. What we really need is the total in hectares. We can see within Martapura we have 1, 2, 3, and 4 polygons, shrub and semi-shrub. Already with the area in hectares identified for us. I just need to not take any of these areas at face value, and I need to be corroborating those. That is the work that I need to be doing. So before taking these, just like I added in here using the field calculator, For Martapura, I added in area in hectares. I'm actually going to go on. There's also shape area. I just want to make sure that these fields and values are not already existing within our attribute table. So let's check that. There is shape area, and that, yeah, it looks pretty close. So what we're computing here in square meter seems really close to this estimate of theirs in square meter, which tells me that we could reasonably go and trust their estimates. Yep, we're really in the very close ballpark. We're very, very close and really only differing by the tens of meter squares. I think that's very, very low error. So we should go and trust their hectareage estimates. So I'm just quickly going to bring together the hectareage estimates so that we can estimate them. I'll just use the Indonesia spreadsheet to do some of these calculations pretty fast. So we were looking at the attribute table on QGIS. Here we were. All right. So now specifically for Martapura, we had 17.82 hectares plus 64.69 hectares plus 91.8 hectares plus 35.68, and that was a total of 309.99 hectares. And that is what I'm going to go and put here, 309.99. All right, and I'm going to calculate the other two right now. So let's close that. You don't really need to use field calculator to derive this. You can just go in here and trust these estimates. So for Subanjariji, we have 36.76 hectares, 2999.60 hectares. Seems to be the largest piece, the largest of the pieces. We have 114.78, and we have 3471.76, the largest thus far. Clearly, we know the relative sizes of these forests already. Okay, that looks pretty great. We can go and update this number here to 6622.9. Next thing we are looking at is Banakat, and that is a bigger area here. All right, Banakat, we have 92.98. We have 2561.23. We have 240.66, and we have 3862.88. So it's where the rest of our area is at. Clearly seems to be adding up meaningfully close to. So this number is 89.7.75. And I just want to add across all of these three regions to see what we get at. We get 15,880.64, which is very close to 16,000. So for this purpose, I'm going to run with this estimate, 15,880.64, approximately equal to 16 kilo hectares, right? So now we know the total area. Amazing. So we've made this visual now for Indonesia and Mozambique. And next thing we need to set ourselves up for is to be able to build this current land cover map, percentage forest, and average deforestation rate. So let's get down to that. I want to show you how I do that. First things here is you will see that I have built a large code project already which can do a lot of these things, so we're going to rely on that code project. This is what the structure of that code project looks like. What I need is just have this one notebook. It does most of the data imports from the large data sets like Modus and Dynamic World, and also produces the outputs for different, it produces outputs like this using a naming convention of the land cover and the land cover change to different files. And we can then open these files separately and study the changes in those files. All we need to do is then set up the shape files like this for Indonesia and Mozambique meaningfully, and we'll be able to operate. We don't need to worry about any of the other pieces folders because they are for analysis that we've done in the past. The one thing I will additionally need to download is this thing called futures utils, because this really has the code behind being able to derive all these things from and use the respective Python libraries like Gmap that I use, which I've set myself up for. So this has, methods for getting soil organic carbon, above and below ground biomass from NASA Oak Ridge National Lab, and the Modus yearly land cover data set from this source, which is from Google Earth Engine. So we already have built all of this. So we're just going to rely on that. So just to set myself up, I'm going to first download the notebook. I'll share this code with yourselves later for those who need to be making these computations as and when needed. So, and I will also go ahead and download this futures utils, and then I will set myself up for it. I'll see you in the next video when we are completely set up, and we'll start from there.